Okay. We can start na raw. Okay lang yung audio?
Yes po.
What about the projection?
Okay lang rin, sir.
Okay, thank you. I-connect lang natin yung last natin na pinag-aralan, ano? Last time we talked about the different gas laws, and the gas laws will tell us the relationship of the properties and components of a gas with its physical parameters like volume, pressure, and the extraneous parameters such as temperature and pressure. This afternoon will be, or evening, meron tayong 4 hours and same rules will apply. Ano? I will give breaks in between so that you can recover your mental energy. Kasi mahirap din mag-lecture ng straight, ano? Baka masaturate tayo. Sorry, I was not able to give you a lecture for the past 2 days. My schedule is unpredictable. Ano? So right now we'll be having a lecture up until 9 p.m. So if you want to eat, you may do so. But I suggest again na during this time of lecture, you devote your 4 hours. Minimize muna yung ating social media and distractions. If you can have a separate room of your own, it's better. Okay. You have your coffee with you. Kape din kayo? Okay. So in this part of the lecture, we'll be talking about solutions. Ano? Solutions are will form quite a big part of your board exam, both in Module 1 and in Module 5 and in Module 3. So a solution is basically the combination of a solute and a solvent. So pag sinabi nating they are a combination, ibig sabihin they are mixed physically. They are together physically. Solutions are not chemical combinations. Take note, solutions are not chemical combinations. They are physical combinations. In a solution, there are two components, sinabi dito, the solute and the solvent. And take note, the definition of the solvent is that substance which has a greater amount. Ulitin ko, ang solvent ay ang material or substance that has the greater amount. So for example, pag sinabing alcohol solution, pag sinabing alcohol solution, and in 100 ml of that solution, 95 ml is alcohol and only 5 ml is water. If in that solution, 95 ml is alcohol and 5 ml is solution, the solvent is alcohol and the solute is water. No? Kung sino yung mas malaki yung concentration, kung sino yung may mas malaking concentration or amount, siya yung ating solvent. So, when we describe solutions, we usually use the term KSP, no? The constant of the solubility product. So, KSP means the constant of the solubility product. So, in terms of KSP, we have three types of solutions. Meron tayong three types of solutions. in terms of KSP, saturated, unsaturated, at saka supersaturated. Pag sinabi natin KSP o constant of the solubility product, we are trying to describe the amount of ions that have dissociated from the solute into the solvent in relationship with the maximum amount of solute particles that the solvent can handle. Ulitin ko, pag KSP, we are talking of the maximum amount that that solvent can handle versus the amount of ions that have dissociated from the solute. The amount of ions that have dissociated from the solute. Kasi ano bang nangyayari? Meron kang malaking solute particle, for example, a big chunk of acid, nilagay mo sa tubig. That big chunk of salt will continuously dissociate as sodium and chloride ions. So, etong dami ng ating solvent, meron lang siyang maximum amount of solute or ions that it can hold. So, KSP will tell us, have we reached that maximum? No? So, if we have reached that maximum, then that is a saturated solution. If you add more solute, even if you have already reached KSP and you did not alter the characteristics of the solution, ano ibig sabihin? Hindi mo ina-agitate or hindi mo tinataasan yung temperature, that additional ion, those additional particles that you have added will not integrate into the solution. And therefore, they will crystallize out. Ano? So, if, for instance, you have reached KSP, yet you added some solute particles, with the advent of increasing agitation, ginagalaw mo yung solution, therefore, mas nag-i-interact yung particles, yung solute with the solvent particles, or tinaasan mo yung temperature such that kahit konti lang yung solvent na available, because they are moving a lot, yung molecules, they are moving more, they can disintegrate the solute. Therefore, in that instance, na-reach ang KSP, agitate, or uminit, the solute will still dissolve in the solvent. Therefore, that is a supersaturated solution. So in a supersaturated solution, the amount of solute is greater than the maximum, which is KSP. So when that happens, that is a supersaturated solution. And in the minute way, there is crystallization going on continuously. Kahit hindi mo nakikita na mayroong precipitate, crystallization is happening in that supersaturated solution. Kabaliktaran naman, if you have not reached the constant solubility product, KSP, then that is an unsaturated solution. Kung ang dami ng solute, hindi pa niya naabot yung threshold ng KSP, that is an unsaturated solution. Okay? So, uulitin ko, solutions dependent on the relationship to KSP. KSP stands for the solubility product coefficient or constant, and that is the maximum number of solute particles that the solvent can hold, that's KSP. If you have reached that maximum, you are in a saturated state. If you exceeded that maximum, supersaturated, and if you have not yet reached that maximum, ibig sabihin pwede ka pang magdagdag and it will still dissolve, that's an unsaturated solution. Okay. So in the board exam, they will ask you, ano yung parameter for determining whether a solution is in saturated form, unsaturated form, or in a supersaturated form. That will be KSP. Okay? Ano yung parameter natin? KSP. Okay. So right now, we're talking of the factors that will tell us how soluble a substance is into a solvent. Kung gaano magdi-dissolve yung solute in the solvent. These are the factors affecting solubility. There will always be a question in the boards concerning the factors affecting solubility. So in our dosage, dosage and drug delivery systems, ito yung ating ina-alter so that we can increase the solubility and therefore create a homogeneous solution in our preparations. So first would be the nature of the solute and the solvent. So in chemistry, the rule will always be like will dissolve like. Ano? So, ibig sabihin nun, if the solvent is lipid, then the type of solute, sorry, may wrong card. The type of solute that will dissolve in that solvent will also be lipid. Um, on the other way around, if your solvent is hygroscopic or hydrophilic, ibig sabihin, much like water, then therefore your solute will also be highly soluble in that solvent if it is very polar or if it is ionic. Ano? So, like will dissolve, like um, um, please remember this table. Kung ano yung descriptive term and ano yung parts of solvent required to dissolve one part of solute. This will come out in your Module 1 and Module 5. The descriptive term and the number of solvents required to dissolve one part of solute. So, dadaanan lang natin, very soluble, less than 1. Ibig sabihin niyan, kung meron kang 1 gram of solute, that 1 gram will already be dissolved by 1 gram of solvent. So kapag ganun yung ating solubility description, that solute is very soluble, less than 1. Freely soluble, 1 is to 10. Ano ibig sabihin yan? If you have 1 gram of solute, that 1 gram of solute will be dissolved by 10 grams of solvent. To 10 grams of solvent. We will be using freely soluble kapag ganon. Soluble, which will be your board exam question, will be at 10 to 30 parts solvent. Soluble at 10 to 30 parts solvent. Ulitin ko, kasi ito yung tanong sa boards always, soluble 10 to 30 parts solvent. Sparingly soluble 30 to 100 parts solvent. Slightly soluble 100 to 1000. Very slightly soluble 1000 to 10,000, and practically insoluble greater than 10,000. So how do we remember this table? So tuturuan ko kayo paano remember ng table. In the boards, what they will ask will be, they will tell you the amount of solute and the number or parts of solvent, usually in ml, required to dissolve that particular amount of solute. So for example, 1 gram or let's say 30 grams of the solute was dissolved by 4,300 so on so forth ml of solvent. Okay? So anong una mong gagawin? Kukunin mo yung ating ratio. So yung 30 grams na yon, dissolving in 4,000 plus ml, you're going to take the ratio and determine how much solvent is required to dissolve 1 gram of that solute. Okay? Kuha niyo yun? So, ratio and proportion, you get 1. No? You proportion to 1. What's the next step? You recreate this table. Hindi pwedeng memorize niyo yung value. Kasi that is a room for error. No? Hindi pwedeng memorize niyo sparingly soluble 30 to 100. No. The best way to answer that will be to recreate this table. Isulat niyo tong table na to sa side ng questionnaire. Ano? Kailangan isulat niyo ulit yung table para wala kayong walang error in recalling. So, sulat niyo yung table sa kabila. How do you recreate the table? Start kayo sa soluble. Etong left muna ang gawin nyo. Start kayo sa soluble. And then, as you go up, freely and then vary. Ano? Freely and then vary. Then, balik na naman kayo sa soluble. Sparingly, slightly, and then very slightly. Sparingly, slightly, and then very slightly. And then last would be insoluble. So ulitin ko, paano gawin yung left side? Sulat nyo, soluble, and then freely, and then very. And then balik sa soluble, sparingly, slightly, very slightly, and then insoluble. So after you have made the first column, madali na lang yung pangalawa. So, yung second column, you start with soluble, sulat nyo 10 to 30. And then you give out the sparingly 30 to 100. Dito tayo nagkakamali. Kaya siya tinatanong sa board exam. Kasi napagbabaliktad nasan yung 30. Ano? So, si soluble, 10 to 30. Si sparingly soluble, yung 30 to 100. Kung nakuha nyo na to, kung ano yung pinagkaiba ng soluble and sparingly soluble, madali na lang. Ano? So, we move backwards, 10, 1 to 10, less than 1. We move forwards, 100, 100 to 1,000, 1,000 to 10,000, greater than 10,000. So, my tip for the boards will always be to rewrite this table. Huwag niyong hulaan. Sulat sa gilid. And then, how do we write? Una yung left, and then you fill up what is on the right column. Always differentiate soluble and sparingly soluble. Then eto, pwede niyo na siyang i-fill in. Bakit ganon? Kasi in the boards, ang dami niyong kailangan i-memorize. You should have a system of remembering little bits lang that are the most important, even in the table. So, when we say solubility, when we say solubility, we are referring to a solid usually dissolving in a liquid. A solid usually dissolving in a liquid, and that is solubility. Pag sinabi nating miscibility, that is a liquid dissolving in another liquid. Miscibility, liquid dissolving in another liquid. So, dito, ability of one substance to mix with another substance. But technically speaking, miscibility is liquid to liquid solubility. Liquid to liquid solubility, that's miscibility. Okay. Technical definition of solubility will be number of grams of solute dissolved in 100 grams of water. Technical definition for solubility, number of grams of solute dissolving in 100 grams of water. Pause ko muna, teka lang. Teka lang. Okay. So kanina, yung previous slide will be the factor that has been affecting solubility is the nature of the solute and the solvent. Right now, we'll be talking of temperature. So madali lang siya. Balik tayo sa kinetic molecular theory of matter. As the solute, as the particles move more, they will integrate into the mixture more. So as we increase temperature, we are also increasing the solubility of most solids. But take note, we are decreasing the solubility of a gas in another gas or in a liquid. Bakit? As the solutes, the solids move because of increased heat energy, they will integrate and diffuse more into the solvent medium. However, if a gas moves more, take note dito, yung gas natin, it's already in solution with the liquid. So ang ating solute ay ang gas at ang ating solvent ay ang liquid. They are already in solution. As you increase the temperature of the system, the gases will move more. No? They will move more. And so when they move more, they will separate from the liquid. Recall nyo yung Henry's law of pressure. No? Kapag ating Henry's law of pressure, temperature, and solubility of a gas. Habang gumagalaw yung gas, they will escape from the solvent. So if you increase temperature, the solubility of a gas will decrease. No? So in terms of temperature, we have two types of solutions. And again, in terms of temperature, you have two types of solutions. If your solution is exothermic, ibig sabihin, the substance, the solute, as it dissolves in the solvent, it will release heat energy. No? If your substance is exothermic, the solute, as it dissolves in the solvent, will release heat energy. If your substance is exothermic, increasing the temperature will increase the solubility. Why? In an exothermic system, the heat that is in the solvent molecules will progressively disintegrate the solute aggregate. So, parang kung ito yung aking solute aggregate, and etong fingers ko, yung aking solute particles, if my system is an exothermic system, ito yung aking solvent molecules, if I heat this up, no? If I heat this up, it will disintegrate the solute particles more. So yun yung exothermic system. If my system is an endothermic system, ano ibig sabihin? For this solute aggregate to disintegrate, para maghiwalay siya, kailangan mag-absorb siya ng inyong temperature, ng inyong heat. If my system is an endothermic system, para siya ay mag-disintegrate, it has to absorb heat. However, if you increase the heat in the system, yung heat that is innate in the system must already been increased by the heat that you added. So, nag-absorb na siya ng heat in the first place, and therefore, addition of heat will prevent disintegration of the solute aggregate. So, How to remember this one? If you say endothermic, the container will be cold. And therefore, if you add heat more into that system, instead of the container being cold, it will be hot. For that system to dissolve, it needs to be cold. If you add heat, it will be hot, and therefore it will not dissolve. Okay? So, in terms of temperature, we have two types of solutions. Are they exothermic or endothermic? When we say exothermic, when you touch the container, it will be hot. And at that instance, when it is hot, it will dissolve. So when you progressively increase the temperature of the system, the container becomes hotter, and therefore the solute will dissolve more. If your system is endothermic, the container will be cold. And that container being cold means there will be lots of solute dissolving. And therefore, when you add heat into that system, that container becomes hot, and if it is endothermic, the solubility will decrease kasi kailangan malamig yung environment. Example of an endothermic substance will be potassium hydroxide and magnesium hydroxide. Endothermic substances are usually alkali and alkaline earth bases. Potassium hydroxide and magnesium hydroxide. They are endothermic. So, a question in the boards will be, what will you do? Questions of boards, especially in PACOP, what will you do to increase the solubility of potassium hydroxide? You place the container, you fill the environment with something cold, for example, ice or a distillation setup. So, condensation setup, kung saan malamig lang palagi yung paligid. And that will increase the solubility of potassium hydroxide. So, the next factor affecting solubility, especially for gases, will be pressure. So, recall nyo, anong gas law ito? As you increase the pressure, you are driving the gas particles into the solvent or the liquid, and that will increase its solubility. So what is this gas law? As you increase the pressure, you increase the solubility of the gas. Okay, this is Henry's law. As you increase the pressure, you increase the solubility of the gas into the liquid. Next factor will be the particle size or the surface area. So ganito lang yung relationship. If eto yung aking particle, surrounding it will be surface area. Okay? If I cut the particles into smaller chunks, okay, the individual particles will be smaller, but the surface area will be larger. Ano? And solvent molecules will interact with your particle through the particle's surface. And so if you have an increased surface area, you will have more space, you will have more chances of interacting with the solvent. And therefore, if you increase the surface area, more interaction with the solvent, increased solubility. When you decrease particle size via comminution, you are going to increase the surface area, and you are, in effect, increasing its solubility. particle size, and surface area. Okay. So the next factor affecting solubility is the presence of salts. Remember that salts are products of neutralization of an acid and a base. Therefore, etong salt na ito will have a cation and it will also have an anion, a positive charge and a negative charge. Ngayon, yung salt, it's a third entity in the system. What are the three entities? The solute, the solvent, and the salt. Ano? So, if the solute interacts with the solvent and the solute is progressively disintegrated into the solvent, that system, etong dalawa, ito yung solution. Now, if you add a solute, there can be two phenomena that will occur. If you add a solute, two things can happen. It's either salting out or salting in. If you add the third entity, the solute, two things can happen. Salting out or salting in. Salting out means if you add the salt, you will decrease the solubility of the solute into the solvent. Ulitin ko, salting out means when you add the salt, you decrease the solubility of the original solute in the solvent. When you say salting in, when you add the salt, you increase the solubility. So dito magkakatalo. Ano yung nangyayari sa salting out at ano yung nangyayari sa salting in? Salting out, you decrease the solubility of the solute. Salting in, you increase the solubility of the solute. Pabaliktaran niya na, salting out, decrease solubility. Salting in, increase solubility. So, what are our examples of salting out? So, this is in biochemistry. When you have an amino acid solution, you have water, and in that water, you have dissolved amino acids. When you add a salt, our standard salt for amino acids will be ammonium sulfate. When you add ammonium sulfate, what happens? The amino acids, which have positive and negative charges, interact with water. Ano? And that interaction causes the amino acid to be dissolved. Ngayon, when you add ammonium sulfate, which has a stronger charge than the amino acid, kasi yung amino acid natin, they are weak acids dahil mayroon silang carbon. But ammonium sulfate does not. So it is a stronger salt than the amino acid. They have stronger charges than the amino acid. When you add the ammonium sulfate, what happens? Instead of the amino acid interacting with the water, the ammonium sulfate will be the one interacting with the water. And therefore, it displaced the amino acid from interacting with water. And therefore, there will be precipitation of the proteins of the amino acid. The solubility of the amino acid decreased. So that is salting out. But there can also be a phenomenon of salting in. Again, in proteins and amino acids. At first, napapansin mo, yung inyong solution, sorry, may stain ng tea, yung inyong solution, sa simula, paglagay mo ng amino acid solute, hindi nang didissolve. Nag-stir ka na, tinaas mo na yung temperature, hindi pa rin nag-dissolve. Ngayon, nagdagdag ka konti lang, versus salting out, konting ammonium sulfate lang. No? Pagdagdag mo ng konti, napansin mo, those amino acids that have not dissolved in the presence of little ammonium sulfate, they dissolve. Why? Because with the addition of ammonium sulfate, you have increased the effective charge of the system. So tumaas yung total charge and therefore they will interact more with the partial negative of the oxygen atom in water and the partial positive of the hydrogen atoms in water. So salting in means by adding little salt, you increase the solubility. Ano? Salting out, you decrease the solubility and use this to separate the proteins. Salting in, you increase the solubility, use this to dissolve the proteins. Solutions, salting out, decrease, salting in, increase the solubility. So, solutions can be expressed, can be described in terms of the strength of the concentration. Gaano kadami ba ang inyong solute in that solvent? No? So these are our expressions of concentration. So percent by mass. What does this mean? Your solute is measured in grams and your solvent is measured in grams. Percent by volume. What does this mean? Your solute is measured in grams and your solvent is measured in ml. So this is also, sorry, napagbaliktad ko. Sorry na duling. your percent by volume means your solute is measured in volume and your solvent is measured in volume. So, liquid, liquid. Liquid yung inyong solute, liquid yung inyong solvent. When you say percent mass per volume, your solute is measured in grams and your solvent is measured in ml. So this is your grams per 100 ml, grams per 100 grams, ml per 100 ml. Eto, parts per million, you use this for measurement of the highly toxic substances. For example, the amount of heavy metal in the air or the amount of an endocrine disruptor in the plastic that you have or in the drink that you're taking. For example, when you drink instant coffee, your toxic substance, which is acrylamide, is measured in parts per million. So your maximum intake of acrylamide should not exceed 400 parts per million per day. So proof will be the unit of concentration for describing alcohol. Proof, pag nabasa nyo proof, automatic associate with alcohol. Ano? So, the easy way to understand proofing will be you get the percent strength of the alcohol, you multiply it by 2, and that is the proof strength. Percent strength times 2, that's the proof strength. So, kapag tinanong sa boards, how many or how much in percent strength is 30 proof 30 proof equivalent to. So, ibig sabihin nun, 30 proof, that's 15% alcohol. Moles, please take note, this is an essential skill for taking the boards. How to determine the number of moles in a material. So, to get the number of moles, We're using Avogadro's in describing moles. So for example, if your material has a molecular weight of 20, and the weight of the mass of that material is 40, then therefore you have 2 moles of that material. So, ano ibig sabihin ng 2 moles? You have 2 times Avogadro's number, and that will be the number of particles in that particular mass. So, example, if ang ating molecular weight ay 20, ang ating mass of the material is 40 grams, then ibig sabihin I have 2 moles. Ibig sabihin nun, in 40 grams, I have 2 times 6.023 times 10 to the 23rd. Yun yung number of particles present in 40 grams. No? So next will be mole fraction. Pag sinabi nating mole fraction, gaano kadami yung moles ng ating solute over the total moles of the solution. So for example, if ang total moles of the solution is 20 moles solute and solvent, and you only have 1 mole for the solute, our mole fraction will be 1 mole of the solute over 20 moles of the solution. So ano yung importance nun? Ang importance will be in the determination of molality. Kasi in molality, our solute is a number of moles, but they can ask how many moles of the solvent is present. So you get first the molality, solvent, kilograms, and then you get the mole fraction. So yung mole fraction natin, moles of the substance or solute over total moles of the solution. So by inference, malalaman natin na yung difference nitong dalawa, substance and solution, will be the solvent. So you get the moles of the solvent from here. Ano? Kuha niyo yun? Nakakasunod? You get the moles of the solvent from the mole fraction, and then by using molecular weight, you derive the grams of solvent. And then you convert the grams of solvent into kilogram of solvent, and you will get molality. So, complex konti yun. So, uulitin ko. The concept of determining the number of moles, the knowledge of mole fraction, and molality, etong tatlo, they are usually used in the same question. Mole, mole fraction, and molality. The question will be, determine the molality of the solution with a mole fraction, this one, a weight of the solute, this one. So, anong mangyayari? Una mong gagawin, you get the mole fraction, the mole of the substance of the solute, you subtract the moles of the solute from the total moles of solution. And therefore, you will have total moles of the solvent. Next, you get the total moles of the solvent, and you determine the mass in grams of that solvent. After you have determined the mass in grams of that solvent, you convert that into kilograms. Then, kunin mo lang ulit moles of the solute and the kilograms of the solvent, and you have answered the question already. What is the molality of the solution? Molarity means moles of solute per, take note, liter of solution. Molarity, please take note. tatanong sa boards, or para hindi kayo maguluhan sa boards, molarity, big letter M, moles of solute per liter of solution. Molality, moles of solute per, take note, kilogram of solvent. Molarity, big letter M, solute per liter of solution. Molality, small letter M, moles of solute per kilogram of solvent. Moles of solute per kilogram of solvent. I cannot stress this enough. Dito nagkakabaliktad, nagkakamali ang isang magte-take ng boards. No? Molar, molal. Molar, big letter M. Molal, small letter M. Big letter M, liter of solution. Big letter M, liter of solution. Small letter M, kilogram of solvent. Small letter M, kilogram of solvent. Please guys, dami nagkakamali dito. Huwag kayong magkamali dito. Normality will be a very good concept to understand when you are facing titration questions, which will be seen in your module 6. Yung number of moles natin, not the entire molecule will be important in titration. Only that part of the molecule which interacts in a chemical reaction with your titrant or your titrant. No? So, sino lang yung parts ng titrant at ng titrant na mag-i-interact? So, yung parts na yun lang yung bibilangin mo. So, yung part na binibilang mo will be the equivalent. So, for example, when we say sulfuric acid, H2SO4, sulfuric acid will have a different number of moles from the number of equivalents. Let us say you have 2 moles of sulfuric acid. But sulfuric acid will give away 2 portions that will interact with your titrant. So 1 mole of sulfuric acid will give you 2 equivalents. So, for example, if I am going to take the molarity of sulfuric acid and I have 1 molar of sulfuric acid, it will be different when we are talking of normality, because sulfuric acid has 2 equivalents per mole of the solution. Therefore, if I have 1 molar sulfuric acid, that is equal to 2 normal sulfuric acid. 1 molar sulfuric acid has 2 participating protons, and therefore we have 2 normal sulfuric acid for 1 molar of sulfuric acid. No, we are talking of the part of the molecule that interacts. That's the equivalent. So more of this in our future discussions. Okay, we now move to acids and bases. Acids and bases. Very high yield concept in the board exam. There will always be a question on acids and bases. Particularly, what definition are you using to describe the acid and the base? What definition are you using? So, to understand acids and bases, we need first to understand what electrolytes are and what non-electrolytes are. Kapag sinabi nating electrolyte, pag nilagay mo siya into pure water, that substance will dissociate such that there will be ions embedded in the pure water that will carry a charge so that the circuit becomes complete when you place a positive electrode and a negative electrode. So, para siyang circuit sa inyong physics. Yung circuit natin complete and there will be movement of electrons if the two poles are connected, no? If the circuit is uninterrupted, there will be movement of electrons. But ngayon, instead of having a physical connection between the two electrodes, our circuit here, the connection will be, nakikita ba? Ano ba ito? In my video. So, ayan. Yung circuit natin, ganito, complete. Yung connection ng isang portion and the other one is uninterrupted. When we say electrolyte solution, ito yung example natin, may water dyan, ano? Suppose this is pure water. An electrolyte solution will be a solution where the solute that you added in the solution will be able to carry the charge from one electrode interacting with the solution and transfer that charge to another electrode. No? Ibig sabihin na kumpleto mo yung circuit. So ano ibig sabihin nun? Yung dinagdag mo into the solution, it is able to transfer the electrons from one electrode to the other. No? Kinary ng electrolyte yung charge. So, ibig sabihin lang nun, electrolytes are conductors. So, based on this, we have two types of electrolytes. They can be weak electrolytes or strong electrolytes. Pag sinabi nating strong electrolyte, yung inyong substance completely dissociated. For example, hydrochloric acid. Yung ating formula for hydrochloric acid is HCl. When you place the hydrochloric acid HCl in pure water, walang matitirang HCl na hindi naghiwalay. Ibig sabihin, lahat ng H naghiwalay sa lahat ng Cl. There is complete dissociation. And that complete dissociation will mean that HCl is a strong electrolyte. Lahat ng kuryente, ipapadaloy niya to the other side. Pag sinabi nating weak electrolyte, in a molecule of the substance that you added, not all of the particles, ulitin ko, not all. So, ibig sabihin there is incomplete dissolution. Not all of the particles will disintegrate. So, example of that will be sodium monobasic phosphate. Sodium monobasic phosphate. So, hindi lahat ng NaHPO3 ay naghiwalay into sodium, proton, phosphate. Mayroong iba, sodium lang yung humiwalay. Mayroong iba, proton lang yung humiwalay. So, ibig sabihin, sodium monobasic phosphate is a weak electrolyte. Ano? So, these are the types of electrolytes. You have weak and strong electrolytes. And lastly, kung yung electrolytes, they will allow the conduct of an electron from one electrode to the opposite electrode. A non-electrolyte will not dissociate and will not conduct electricity. A non-electrolyte will not conduct electricity. Ibig sabihin, the circuit will be broken. Ano? The circuit will be broken. So paglagay mo ng dalawang electrodes, mapuputol yung circuit and therefore walang light bulb na magla-light up. No? So example of a non-electrolyte will be glucose. No? A non-electrolyte is glucose. So ibig sabihin, if you have pure glucose and you make and if you dissolve it in pure water and you add two electrodes, the light bulb will not light up. Ano? So, in your higher forms of learning and in your biochemistry, maybe ma-encounter nyo, in your clean farm, ma-encounter nyo, the formula for determining plasma osmolarity. Ano? So in that formula, to determine plasma osmolarity, a very big factor is given to sodium. And a smaller factor will be given to glucose. Why? Because sodium is an electrolyte, it will attract more of the water, and therefore it will have a bigger percentage or a bigger contribution towards osmolarity. But glucose, because it is a non-electrolyte, it will attract less water compared to sodium. Therefore, the contribution of glucose in plasma osmolarity will be lesser compared to sodium. That is why for the concentration of glucose, to get plasma osmolarity, it will have to be divided by 18 to get plasma osmolarity because it is a non-electrolyte. So it has already been 55 minutes. Let's take a 10-minute break. 10-minute break muna. Meron bang questions?
None, sir.
Okay. 10-minute break. Yung projection and audio.
Yes po, sir.
Okay, thank you. Let's pick up our discussion kung ano yung magkaibang definition ng acids and bases. Paki-memorize ito. Ano? Paki-memorize itong table na ito. Dahil 2 to 3 questions in Module 1 will just ask you to identify a particular acid or base, if it is an acid or base, depending on the theory of Arrhenius, Bronsted-Lowry, or Lewis. No? Merong ang question will be merong chemical reaction, usually a neutralization reaction, and you are going to identify sino doon yung Bronsted-Lowry acid or sino doon yung Lewis Lewis base or Lewis acid. So ang choices nyo would be the reactants and the products. So that question in the boards will essentially try to test if you have understood the concepts on the different theories. No? So, Arrhenius, start tayo. Arrhenius. Pag nakita niyong Arrhenius, or pinapa-identify si Arrhenius na Fury, the essential thing to remember will be an acid and a base are both donors. No? Arrhenius, acids and bases are both donors. But they differ kung ano yung kanilang dinodonate. Ano? Arrhenius, both are donors, but they differ on what molecule they donate. Arrhenius acid will donate a proton or hydronium. Arrhenius acid will donate a proton or hydronium. And an Arrhenius base will donate a hydroxyl group. An Arrhenius base will donate a hydroxyl anion. No? Ulitin ko, Arrhenius, both will donate, but they donate different things. Acid, proton, base, hydroxyl anion. No? Next theory will be the Bronsted-Lowry theory. Bronsted-Lowry theory, focus kayo sa proton. Bronsted-Lowry theory, focus on the proton. Pero magkakaiba yung acid and base in terms of how they relate to the proton. Magkakaiba yung relationship to the proton ng isang acid at ng isang base. Sa Bronsted-Lowry theory, yung ating acid, it will give off the proton. Bronsted-Lowry acid will give off the proton. Bronsted-Lowry base will accept the proton. A Bronsted-Lowry base will accept the proton. No? Arrhenius, giving off, but giving off different things. Bronsted-Lowry relate to the proton. One will accept, one will give off. No? Lewis theory, we focus on the electron pair. Lewis theory, we focus on the electron pair. An acid will accept an electron. An acid will accept an electron. A base will donate an electron. A base will donate an electron. No? So, recap natin yung tatlo. Arrhenius, giving off different things. Acid will give off a proton. Base will give off a hydroxyl. Bronsted-Lowry, we talk of the proton. Bronsted-Lowry, proton. An acid will give off a proton. A base will accept a proton. Lewis theory, we focus on the electron. The acid will accept the electron and the base will donate the electron. So, pag sinabi nating Pearson's HSAB, ibig sabihin ng HSAB, hard, soft, acid, base. Ulitin ko, HSAB, hard or soft, acid or base. So pag sinabi nating hard acid, they are electron acceptors with high positive charges. Electron acceptors with high positive charges. Pag sinabi nating soft acid, they have usually an intervening atom which makes them relatively less a carrier of a positive charge. Ibig sabihin, dahil mayroong intervening atom, which is usually carbon, a soft acid will have its cationic charge dissipated. Ibig sabihin, nawawasak or nasosoften noong carbon yung positive charge. Kaya siya soft acid. So Pearson's HSAD, Pearson's hard and soft acid base. Ano? So in the board exam, yung questions nagse-center sa tatlo. Are you able to differentiate an Arrhenius, a Bronsted-Lowry, or a Lewis acid and base? So, let's give off examples. Pakisulat ninyo. Acids are mineral acids. Arrhenius acids are mineral acids. Ibig sabihin, example niyan, hydrochloric acid. They can also be carboxylic acids. Example will be acetic acids. Ano? So, Arrhenius can be mineral or a carboxylic acid. So, kapag sinabi natin carboxylic acid, we talk of the carboxyl functional group. R, C, double bond O sa taas, bond OH. Those are the carboxyl acids. A Bronsted-Lowry base, no? So, pinapakita dito ang, teka lang, yung E-pointer. So, focus kayo sa chemical equation and reaction dito sa baba. No? Ammonia plus water will cause the formation of ammonium and the hydroxyl. So dito makikita nyo the presence of the Bronsted base and the Arrhenius base. So Arrhenius, so tingnan natin para ma-apply nyo yung definition. An Arrhenius base will give off hydroxide or a hydroxyl anion. Ano? Will give off a hydroxyl anion. So sino dito yung nag-give off ng hydroxyl anion? This will be water. Ano? So your in this system, you liberated a hydroxyl anion. Therefore, here you have an Arrhenius base. Ano? Pag sinabi nating Bronsted-Lowry base, no? Pag sinabi nating Bronsted-Lowry base, you have a proton acceptor. So here, in this system, the one that gave off the proton is water. Therefore, here, water is our Bronsted-Lowry acid. And here, because ammonia accepted the proton, ammonia is our Bronsted-Lowry base. Here, Bronsted-Lowry acid gave off the proton. Bronsted-Lowry base accepted the proton. Okay? So, ito yung na-form. Nag-give off siya ng proton papunta dito. Ngayon, if dito tayo magfo-focus, if this reaction is freely reversible, if this reaction is freely reversible, ammonium, the ammonium ion, ammonium cation, is a quaternary cation, it will be the one to give off the proton. So in this side of the reaction, ammonium is our Bronsted-Lowry conjugate acid, and hydroxyl is our Bronsted-Lowry conjugate base. Ano? When this gives off the proton, this is the conjugate acid. And if this accepts the proton, this is our conjugate base. No? Kuha yan. Next, here you have ammonia and water. No? So, focus tayo dito sa ammonia. Ngayon naman, ipapakita ko why the ammonia and the proton that it accepts demonstrates the Lewis theory. No? Paano niya dinidemonstrate yung Lewis theory? Recall natin na yung valence ng nitrogen is 5. And here in ammonia, 3 of the 5 valence electrons are occupied by interacting with hydrogen. And therefore, you have an electron pair, one electron pair in nitrogen. Ano? Merong unpaired electrons dalawa. Ngayon, etong unpaired electrons na dalawa, they will be interacting through a coordinate covalent bond with the hydrogen from water. Ulitin ko, yung electron pair in nitrogen will be interacting through a coordinate covalent bond with hydrogen from water. Ano? So, coordinate covalent bond. Sulat nyo, coordinate covalent bond. Ibig sabihin, 2 electrons are shared from one atom. Coordinate covalent bond, 2 electrons are shared from one atom. And that atom is nitrogen. Ano? Nitrogen, with its electron pair, will give off the entire electron pair to hydrogen. So that hydrogen shares an electron cloud, forming a covalent interaction with nitrogen. Ano? So kapag binigay na ni nitrogen yung buong electron pair niya, it becomes partially positive. Kaya na-form ang inyong quaternary ammonium ion. Kasi yung buong electron pair, yung dalawang electrons na yon, tinapon niya papunta kay hydrogen. And therefore, because it lost electrons, nagkaroon ng electron sink, kumbaga, that became a partially positive atom. Naging, So, dito, dalawang electrons yung tinapon. That is why it is a coordinate covalent bond. Ano palang nangyayari sa ordinary covalent bond? Isang electron lang yung nasa-share. Dito sa coordinate covalent bond, dalawang electrons ang nasa-share. So, highlight ko lang, coordinate covalent bond, dalawang electrons ang nasa-share. Ordinary covalent bond, isang electron lang yung nasa-share. So, here, you have the concept of the Lewis acid. What is our Lewis acid? An electron acceptor. Heavy metals are Lewis acids. Why? Yung heavy metals, remember, in the periodic table, they are in the middle. No? Heavy metals are in the middle. Ibig sabihin, yung kanilang electron configuration, particularly the azimuthal number, will utilize the d orbital. So yung alkali and alkaline earth, remember, they will utilize the s orbital. Yung non-metals at the right side of the periodic table will utilize the p orbital, and the transition metals, which contain the heavy metals. Example ng heavy metals, Diba? You have mercury, lead, silver, gold, many more. They have the D orbital. Ibig sabihin, the D azimuthal number. So, ano ibig sabihin ng D azimuthal number? Yung kanilang electron cloud is shaped in such a way na sobrang malobo. Ano? Sobrang malaki and sobrang kulang. Kasi nasa gitna. Therefore, heavy metals are electron acceptors. If you place a heavy metal in a solution, no, meron kang heavy metal ions there, the reason why they are easily chelated by chelating agents. So dito, kailangan mo nang i-remember yung inyong toxicology. Your heavy metals, they have lots of electron gaps, kulang ng electrons. And EDTA, ethylene diamine tetraacetic acid, EDTA, ethylene diamine tetraacetic acid. Remember, sobrang dami ng kanyang unpaired electrons. You have 6 lone pairs. So bakit 6? So recall na lang natin yung ating, saang lesson ba to? This is in module 6, titration. So, quality control. So yung EDTA natin, ang ating chemical name is ethylene diamine tetraacetic acid. So you have carbon, carbon, double bond sa dalawang carbon. Ethylene diamine. Branching off from the 2 carbons, one amine molecule and another amine molecule. So yung amine natin, RNH2. So you have nitrogen and 2 electrons. So ano nangyari? You have an electron pair here sa carbon, 2 electron pairs here sa inyong nitrogen. So one side of the EDTA molecule has 3 electron pairs or lone pairs, and the other mirror image or symmetrical side will have another 3 lone pairs. Therefore, one EDTA molecule will have 6 lone pairs. So, ibig sabihin, EDTA has so much free electrons. And the heavy metal has so much kulang na electron. Therefore, it will be logical na if you give EDTA via intravenous infusion, you are able to chelate the heavy metal in the plasma or in the blood or in the system, even deposited in the solid organs. Kasi, yung isa, very strong Lewis acid, electron acceptor. Those are the heavy metals. At saka yung isa, very strong electron donor. Ibig sabihin, Lewis base, yung ating EDTA. Very strong electron donor. 6 electron pairs. Therefore, logical na EDTA will chelate the heavy metal. No? Okay? So, yun yung ating clinical application of the Lewis acid and base theory, no? In the principle of chelation, EDTA and heavy metal. Okay? Please remember, kahit itong tatlo lang, wag na to. Kahit itong tatlo lang, before you go into the boards. The question in the board exam can be as simple as this one. You have a material and then they need describe yung properties ng material. Is this an acid or a base? No? So acid, no? From the Latin acidere, meaning sour taste. Acids have sour taste, maasim. They will turn litmus, so recap na lang to, di ko na masyadong i-discuss, it will turn litmus paper from blue to red. Together with metals, remember acids, they have they release proton or hydrogen. And if added with a metal, they will release hydrogen gas. If added with carbonate and bicarbonate, they will release carbon dioxide. So this is the principle in your Seidlitz powder or your effervescent formulation. Kung saan yung formulation ninyo, which usually contains the organic acids, tartaric, citric acid, if added with water, they will release carbon dioxide. And so that carbon dioxide, the gas, the bubble, will be the one to form a layer in between the tongue receptors and the bitter molecule. So yung bitter molecule, dahil hindi siya makakapag-interact with your tongue taste receptors, hindi malalasahan ng isang patient yung mapait or sobrang maalat na gamot because of the carbon dioxide layer in between. So, next, an acid will turn phenolphthalein colorless, or if added with phenolphthalein, it will have no reaction. Why? Because phenolphthalein will convert into purple or pink at a pH of 8.5. So, ibig sabihin, magiging purple or pink siya if your solution is basic. Therefore, if your phenolphthalein is already pink and you add acid, it will turn the solution colorless. Okay? So, with methyl orange, it will form a pink or red color. So, examples natin would be this one. No? Mapapansin nyo, mayroon silang coordinate hydrogen atom. Etong coordinate hydrogen atom, ito yung kanilang nire-release. And therefore, they will satisfy the Bronsted-Lowry definition of the acid. Yung base will be a substance with a bitter taste. So, pag sinabi niyong base, isipin niyo na lang sabon. No? Base, sabon. Bitter taste. Litmus, it will convert red litmus to blue. And phenolphthalein, so board exam question, what is the limit of phenolphthalein? That's 8.5. So 8.5 and above, it will progressively turn from pink to purple. Methyl orange reaction, yellow. That is why we really do not use methyl orange to separate an acid and a base. Kasi tingnan nyo, Roy G. Biv, sobrang lapit lang yan. Hindi mo mababasa yan pag ikaw ay nasa lab na magkakamali ka sa basa. Next, a base. Examples natin would be the metal hydroxides, the alkali metal, sodium and potassium hydroxide, and the alkaline earth metal, calcium hydroxide. So, what is the application here? Sodium hydroxide, if you add it to fat or lipid, you will form a solid soap. Sodium hydroxide, solid soap, and potassium hydroxide for liquid soap. This is the principal difference between yung safeguard na solid, puti, sodium hydroxide yung gamit na base, and yung hand wash na safeguard, which is a liquid. Potassium hydroxide yung gamit. Anong ibig sabihin ng binary acid? A binary acid is an acid whose component is a non-metal. So kung mapapansin nyo, these are halogens. Fluorine, chlorine, bromine, and iodine. Ano? So they are binary acids. Hydrogen plus non-metal. Last time, binary, hydrogen plus non-metal. hydrogen nonmetal, hydrogen nonmetal, hydrogen nonmetal, hydrogen nonmetal. So, dito kailangan ma-understand ninyo that the higher the electronegativity of the nonmetal, the more they become a weak acid. No? Why? If your nonmetal is very electronegative, no? If your nonmetal is very electronegative, ibig sabihin, they will tend to accept more of the electron. Anong mangyayari? Remember that hydrogen here, so focus kayo sa hydrofluoric acid. Hydrogen here is in a covalent interaction with fluorine. No? So if fluorine, which is the most electronegative element, combines with hydrogen, there will be a very skewed polarity. Your fluorine will be very electronegative and your hydrogen will be very electropositive. And because of this, fluorine being very electronegative and hydrogen being very electropositive, therefore, there will be a strong electrostatic interaction. Kaya, ayaw na ayaw i-release ni hydrofluoric acid yung proton. Kasi mayroong electrostatic interaction. Therefore, electronegative elements in your binary acid will be weak acid. Ayaw niyang i-release. And remember, for us to define a strong acid, kailangan ma-release niya completely mag-dissociate. Therefore, HF, hydrofluoric acid, is a weak acid because fluorine is very electronegative, it's very polar. It will not want to ionize. Ayaw niyang mag-dissociate. Next, we have the oxy acids. Ibig sabihin lang ng oxy acid, yung inyong acid molecule has an oxygen atom inside. So, example will be nitric acid. This is your perchloric acid. So, these are oxy acids. Merong oxygen sa gitna. Remember, polyprotic acids. Kung titingnan ninyo, there are two proton particles here, 3 proton particles, 2 proton particles, 3 proton particles. Kaya siya tinawag na polyprotic acid because this acid has more than 1 hydrogen. No? Sulfuric acid has 2, boric acid has 3, carbonic acid, which is your physiologic buffer, has 2, phosphoric acid, still a physiologic buffer, has 3. Take note, kapag polyprotic yung inyong acid, they are weak acids. So, ulitin ko, polyprotic acids are weak acids. Ano? So, ibig sabihin, inside the body, when you inject sulfuric acid, not all, no, exception is sulfuric acid. Punta kay boric acid, sorry. If you inject or if you administer boric acid, as in the case of your eye drops, usually yung ating buffer for the eye drop solutions, yung mga ophthalmic solutions, they are, it is boric acid, yung ating ginagamit na buffer and osmotic agent in the ophthalmic solutions. It's usually boric acid. If you give boric acid, not all of the H3BO O3 will become BO3 plus H plus H plus H. Hindi lahat ganon. Some of it will become H plus H2BO3 or HH plus HBO3. Hindi complete yung dissociation. Ulitin ko, polyprotic acids will have incomplete dissociation. Ano? So therefore, polyprotic acids are weak acids because they have incomplete dissociation. So remember, ito yung application natin. Yung carbon dioxide that you are producing through cellular metabolism, di ba yung ating way of expelling carbon dioxide will be to form carbonic acid, which circulates in the blood, and if it reaches the respiratory epithelium, yung ating alveolar cells, yung mga maninipis na cells in our alveoli, the carbonic acid will be converted into carbon dioxide and water, and carbon dioxide will be expelled into the gas and exhaled. No? So in the body, yung gumagawa ng carbon dioxide, lahat ng cells. But in the body, it is continuously buffered by bicarbonate. No? Carbon dioxide is continuously buffered by bicarbonate. Carbon dioxide forms carbonic acid, which is acidic, as it combines with water, and bicarbonate from carbonic acid dissociates into proton and bicarbonate. Bicarbonate being a base. So meron kayong continuous buffering. So ito yung ating nag-underlie ng physiologic buffering by the kidneys and the respiratory system. So polyprotic acids, ang point doon, carbon dioxide, carbonic acid will exist as a state of incomplete dissociation, which is bicarbonate. And this will underlie your buffering mechanisms. So our special case for the polyprotic acid is sulfuric acid. Why? Because sulfuric acid will produce both complete dissociation, forming sulfate, an ion, and two molecules of the proton, and incomplete dissociation, forming a proton particle and sulfurous acid, or this is your monobasic sulfuric acid, HSO4, monobasic sulfuric acid. Next, let's go to the bases. So yung bases natin, remember, yung ating definition for the Arrhenius, the Bronsted-Lowry, and the Lewis definitions. For Arrhenius, giving off hydroxyl. For Bronsted-Lowry, accepting the proton. And for Lewis, donating an electron pair. So these are the bases, yung definition ng bases. Bases are alkali metal hydroxides. So pag sinabi nating alkali, ibig sabihin they are group 1A of the periodic table. If that element combines with a hydroxyl, an ion, that is a strong base. Remember, alkali, hydroxide, strong base. If alkaline earth hydroxide, it is a weak base. No? Alkaline earth hydroxide, weak base. Alkali hydroxides, soluble in water. Ulitin ko, alkali hydroxides soluble in water. Alkaline earth hydroxides are insoluble in water. Alkaline earth hydroxides are insoluble in water. But we have an exception, which is a board exam question. Our exception is barium hydroxide. Barium hydroxide is soluble in water, even if it is an alkaline earth hydroxide. It is soluble in water. It is the exception. So, board exam question yan. Okay? Okay. Atin na tong napag-usapan kanina. No? Neutralization or days ago. Neutralization is basically the interaction of an acid, a base, forming salt and water. You have a substance, the acid, which has low pH, and a base, which has high pH, forming a substance, the salt, which has neutral pH and water. So that's neutralization. Titration is the progressive addition of a solution of known concentration to a substance of unknown concentration. So your analyte, no? Your analyte will be that substance that you don't know the concentration of. Ano? So, ang gagawin mo, you're going to add a substance whose concentration you know. And then, if you have reached the endpoint, you're going to measure how much of that titrant you have added to the titrand, and you're going to compute by virtue of neutralization and stoichiometry how much really was present in the analyte, in the titrand. No? So, na-perform nyo to sa laboratory. No? So, you know the other, you don't know the other. You measure how much you gave of the other so that you can determine originally ilan yung nandun sa analyte. Okay? An indicator is a substance that changes color, or in the case of your precipitometry, a substance that precipitates out of the solution, which serves as your this is your surrogate marker or endpoint. Yung neutralization point, that is the theoretical perfect combination or equivalence point. So, yung neutralization point, other names niya will be the stoichiometric point, the equivalence point, or the theoretical point. You cannot observe this one. No? You cannot observe this one. This is the point when there is equal amount of acid reacting with the base. This is non-observable. So, hindi mo siya nakikita. Yung inyong nakikita, but not necessarily predictive of the neutralization point, is the end point. Ito yung nakikita mo, yung nag-change yung kulay, nagiging turbid yung reaction, yung system. This is the end point. This is your surrogate, relatively precise indicator that you have reached the neutralization point. No? Okay. So in the board exam, there will be questions on this one. Yung ating pH scale, 1 to 7, 7 to 14, no? That's the Sorensen's pH scale. So yung pH scale na alam natin, 1 to 14, 1 to 7 being acidic, and 7 to 14 being basic, and neutral, such as water, being 7. That's Sorensen's pH scale. So what is pH? pH is basically the potential of hydrogen or the power of hydrogen. So this is the negative logarithm of the hydrogen ion concentration. So uulitin ko, pH is the negative logarithm of the hydrogen ion concentration. So ano ibig sabihin nun? If you're going to write the formula of pH, it's the negative logarithm of the hydrogen ion concentration. So here you have the relationship. As the hydrogen ion concentration increases, your pH will decrease. Ulitin ko, there is an inverse relationship between the number of hydrogen ions in the solution and the pH, which means if your pH is low, as in the strong acids, there will be lots of hydrogen ions. Kabaliktaran with the base. If your base has a lot of hydroxide, ano? So take note, yung value ng inyong hydroxide is negative. You have a negative logarithm. So that will make a pH positive. No? So this will entail your algebra. Okay. So we have special examples here. You have weak acids. A weak acid interacting with water. So water will accept the hydrogen from the weak acid, forming the hydronium anion and liberating your weak acid here. No? Bakit siya weak acid? Because it will not completely dissociate. For a weak base, take note, pansinin niyo yung difference. The weak base will be the one to accept the hydrogen. So if this water molecule releases the hydrogen, you will form the hydroxyl ion and your conjugate acid. So ulitin ko, yung weak acid here, this one, it will give off hydrogen to water, forming this one. And that sole acid molecule will be your conjugate base. Why? Kasi ito, if this is reversible, this will accept the hydrogen and form this one. And therefore, ito, the sole acid molecule is a conjugate base. It will be one that accepts a proton. Ito, one that liberates the proton. Ito, one that accepts the proton. This is your acid. And by liberating the proton, it became the conjugate base. Kuha yon? This is your base that upon accepting the hydrogen becomes the conjugate acid. Kuha yon, yung difference. Very important yun, guys. Para hindi kayo nanghuhula sa inyong pag-compute ng buffer capacity. No? Kailangan maintindihan niyo yon na ang weak acid yung nagbibigay ng hydrogen at after it has given off the hydrogen, it becomes its own conjugate base. No? For weak bases naman, it is a weak base because it accepts the proton. And after it has accepted the proton, it has become its own conjugate acid that will give off hydrogen to reform water. No? So, kung mapapansin nyo, eto, patalon-talon lang yung proton. Therefore, you have a system that stores proton. You have a buffering system. You have a leeway kung saan dadami yung protons, but the pH will not change because it has been buffered. No? Very important, please remember. And water itself ionizes. So yung water na iniinom nyo, meron niyang mga hydronium and hydroxyl ions. Nag-recalibrate, nag-auto-calibrate. So, ito yung ating formulae. Marami. Kanina na-describe na natin ano yung relationship, ng inyong hydrogen ion and ng pH. As the pH goes down, kaya negative logarithm, the hydrogen ion goes up. Because your hydrogen ion is negatively charged, as the pH goes up, the hydrogen ion also goes up. No? Kasi negative logarithm, double inverse tayo. Kung mapapansin nyo, yung pH, the total will be 14. Ito yung derivation for this formula. The total of the pH will always be 14. Now, kailangan mong i-subtract yung iyong basa ng negative logarithm of the hydroxyl ion concentration dahil nag-i-equilibrate yan with the proton in the solution. Therefore, from 14 to get this formula, kailangan mong i-subtract yung inyong base na formula. So this is a derivation of this one. Tingnan nyo. And so, for computation of the strong base, we use hydroxyl. So, for weak acids, take note, meron kang correction, which is 1/2, taking account your impartial dissociation. So, taking account na hindi lahat ng hydrogen pupunta doon sa solution niyo. You've already used your pKa, which we will discuss later in the Henderson-Hasselbach. No? For weak bases, we use the pK of water. With the pK of base later, I will discuss the pKa's. And the logarithm of the base over the salt. Maraming formulas dito, guys. But take note, hindi ito gagamitin niyo lahat. If you have already known etong dalawa, and you know how to work out the Henderson-Hasselbach equation, you can already derive ito. So kahit yung tatlo lang, this one, and the Henderson-Hasselbach, you are good for the boards already. Okay, so it's been another 52 minutes. Let's take a 10-minute break ulit. And then we will resume after 10 minutes and have another 50 minutes. Okay? So take your break muna and maybe you can have your working dinner. So you start your dinner right now in the 10-minute break and then continue. Continue lang. Okay? So I'll be stopping the share. Hello, resume po tayo. Okay lang yung audio tsaka projection. Sorry, di ko rinig. Nakikita niyo ba? Okay. So, as alluded to kanina, yung buffers, ito yung mga substances that when you add into a solution, will protect the solution from changing pH. So, solutions, these are solutions that resist changes in pH when acids or bases are added to them. So, this property results from the presence of a buffer pair na ating inexplain kanina, where there is a weak acid and after it has given off its hydrogen and formed a salt, that weak acid becomes a conjugate base. And that conjugate base will be able to accept protons in the future. And therefore, this ping pong of protons will prevent changes in pH as you add more acid. Ibig sabihin, as you add protons or if you add bases, which will remove from the solutions the protons. It can also be a weak base or its salt. Ano ibig sabihin ng weak base? It will take from the solution protons, and once it has neutralized by accepting the proton, it becomes its own conjugate acid, such that in the future, kapag nagkukulang na ng protons yung solution, that conjugate base will be able to give away the proton that it has accepted before. So, paulit-ulit lang magpipingpong yung mga protons. And therefore, the system is protected from changes in proton concentration or basically, di ba, sabi natin yung pH, it's the power of hydrogen. So, ibig sabihin, yung dami ng hydrogen yung kanyang mini-measure. Changes in pH. No? So, buffers, the elementary definition, yung dapat nyo ma-remember, it's a weak acid and it's in its conjugate base, or it's a weak base and its conjugate acid. So that's how you make your own buffer. No? You just find a weak acid, form a salt out of that weak acid, and the two, yung weak acid and its salt, lagay mo lang dun. That is already a buffer. So, in terms of buffers, no? Dahil ang ating component ng buffer ay isang weak acid or isang weak base, we should also determine how much change in the pH will occur if we alter the concentration of the salt and its acid, weak acid, or its conjugate base. So the relationship that explains the concentration of the salt, the weak acid, its conjugate base, or if we're going to use weak bases, the weak base, its conjugate acid, and the salt, is the Henderson-Hasselbach equation. So yung Henderson-Hasselbach equation, it says the pH of a system will be equal to the Ka dissociation constant plus the logarithm of the fraction salt over acid. Or if we're going to determine the pH of a solution that employs a weak base as its buffer, pH is equal to the Kb dissociation constant plus the logarithm of the fraction of the concentration of the base over its salt. So, ang usual na point kung saan nagkakamali ang students kapag nag-take ng boards will be dito sa fraction, sa logarithm, sino yung nasa taas at sino yung nasa baba. Ano? In the board exam, you're going to have to recall this formula. And so, dapat sakto kung sino yung nasa numerator at denominator na portions. Ano? So, the best way to remember that will be whoever is ionized, ano? It's always over the unionized. No? Whoever is ionized is always above that which is unionized. So for example, dito sa weak acid, yung ating unionized, ibig sabihin, yung substance that has not yet lost its proton, unionized, that's the acid, and it is in the bottom. And the one that is ionized, ibig sabihin, it has accepted the proton or lost the proton. Ibig sabihin, nagbago na yung charge, it's the salt. So, paulit-ulit yon. In the Henderson-Hasselbach equation, the numerator is ionized and the denominator is unionized. Kaya ko, pinapaintindi, nasa yung aking previous slide, eto. Kasi dito nyo, malalaman kung sino yung ionized at sino yung hindi ionized. No? Always in the Henderson-Hasselbach, ionized over unionized. Okay. This is a very difficult slide, but what I want you to understand here is the concept. Ano? Bakit ganito yung formula? Kasi sabi natin, ang isang buffer ay isang substance na mayroong capacity, meron siyang potential to store protons. Kung sobra yung protons, as in you add an acid, it has the capacity to take those extra protons. And when the time comes na magkukulang na yung protons in the solution, it has the capacity to release some of the protons. Therefore, buffers have a working range of pH that they can maintain. At etong working range na to, this is your buffer capacity. The question in the boards, or at least in your PAPO, will be, what are the other terms of buffer capacity? So the other terms of buffer capacity are buffer action, buffer efficiency, buffer index, and buffer value. So these are synonymous terms. Buffer capacity, buffer action, buffer efficiency, buffer index, and buffer value. So, this is the ability, no? Yung measurement natin kung gaano ka-effective yung isang buffer. the ability to resist a change in pH of the solution. So what I want you to look at is this one. So kung mapapansin ninyo, you have the relationship of the acid, its conjugate base, the salt, and the conjugate base. So kung mapapansin ninyo, this is basically your Henderson-Hasselbach equation. Tingnan niyo yan. But you factored in the concentration of the base or the conjugate base. Why? Kasi yung base at saka yung conjugate base together with the salt and the acid, sila yung nagpa-participate sa pagtapon at pag-accept ng protons. So, basically, yung difference ng kanilang concentrations, ng kanilang effective regions of accepting a proton, yun yung measure ninyo ng buffer capacity. It's like you're measuring the space kung saan pwedeng tumambay yung protons. So that's your buffer capacity. So the exact formula will be this toxic formula. What's important here is you know the other name of this exact formula. It's your Koppel-Spiro-Van Slikes equation. For measurement of buffer capacity, to determine exactly the buffer capacity, we use the Koppel-Spiro-Van Slikes equation. Koppel-Spiro-Van Slikes equation. And this is very important, especially in your physical pharmacy, that you know the formula na 2.3 ang ating constant, and we multiply that by the total buffer concentration, C. And take note, ito yung tingnan nyo, we are going to relate the dissociation constant of the acid, no? And its conjugate acid, and raise that to the power of 2. So this is your exact formula, the Koppel-Spiro-Van Slikes equation. Your conjugate acid, gaano kadami? What is the tendency of that conjugate acid? To release the proton. You raise that to the power of 2. And that relationship, you're going to multiply with the total buffer concentration. Gaano kadami yung buffer na ganun yung relationship. And you multiply it by the constant 2.3. Koppel-Spiro-Van Slikes equation. Then you have your approximate formula, a derivation of the Henderson-Hasselbach. And then you have your maximum buffer capacity. Please remember the constant. Maximum buffer capacity will occur when the pKa is equal with the pH. Ano? So ganito lang. Paano nyo maiintindihan yung pH and pKa? When you say pH, you are looking at the environment. No? When you say pH, you are looking at the environment. But when you say pKa, you are looking at the intrinsic property of that substance to either release the proton or accept the proton. pKa, you look at the substance. pH, you look at the environment, you look at the solution. And remember, yung pH in the solution, doon mo makikita ang protons. No? pKa, tendency to release the protons or accept the protons. That is determined by the substance. pH is determined by the environment. When there is equilibrium, no, pantay yung environment, yung dami ng protons ng environment, at saka yung inyong substance. Yung dami ng, yung tendency ng substance to release or accept a proton, when they are in equilibrium, you can determine the maximum buffer capacity. You just multiply kung gaano kadami yung buffer, C, with the constant 0.576. Please remember, maximum buffer capacity, 0.576 multiplied by total concentration of the buffer. Maximum buffer capacity is equal to 0.576 multiplied by the total buffer concentration. So, etong table na to will tell us the different buffer systems in the body, no? Or in your chemistry setup. So, your phosphate buffer system is a physiologic buffer. Ulitin ko, your phosphate buffer system is physiologic. Ibig sabihin, nakikita sa loob ng katawan. Bakit? Remember that inside your cells, in the solution inside your cells, especially in your mitochondrial matrix, no? Doon na-form ang inyong adenosine triphosphate. So, ibig sabihin doon, marami kang concentration, malaki yung concentration ng phosphate ions inside the cell. It is an intracellular anion na phosphate. Yung phosphate na yon ay kinukuha ng inyong ATP synthase to form adenosine triphosphate. And when the cell finally uses the adenosine triphosphate, it will liberate adenosine, 2 molecules of phosphate, or adenosine diphosphate and a pyrophosphate. So, ano nangyayari? Inside the cell, there is a constant flux of phosphate. At kung hindi pa nakakapture ng adenosine yung phosphate, that phosphate can take up protons. Ano? When it takes up 1 proton, it is a monophosphate or monobasic phosphate. When it takes up 2 protons, it is a dihydrogen phosphate or dibasic phosphate. Ibig sabihin, yung phosphate, kaya niyang humawak ng hydrogen. Kaya siya buffer system. Ngayon, yung phosphate, although it is a naturally occurring buffer system, siya din ang nagfa-facilitate na lumaki yung microbes. That is why your microbes, they will try to enter the cell if they are intracellularly infectious kasi nandoon yung inyong phosphate buffer system. The phosphate buffer system supports microbial growth. Bakit? Kasi yung inyong microbes, mapili sila sa pH kung saan sila lalaki. So when you have the phosphate buffer system present, pwede silang lumaki doon. No? Your phosphate buffer system is insoluble to metals. Aluminum, silver, and zinc. Please take note of the metals. You should know that aluminum, silver, and zinc will not form a soluble complex with phosphate. Next will be your borate buffer system. Your borate buffer system is used in external solutions. For example, eye drops and nasal drops. They are used borate buffer system. Remember, this is a polyprotic acid system. For ophthalmic sa mata and sa ilong na drops, even otic drops sa tenga. These solutions are naturally hypoosmolar, and therefore the borate buffer system will prevent changes in pH, but will also add tonicity to the system, such that it becomes isotonic with plasma and tears, yung borate buffer system, yung solution. Etong Feldman's, Gifford, and Atkins-Pantin systems, they are classification of buffer systems relative to the Sorensen pH scale. Ulitin ko. Si Feldman, Gifford, and Atkin, they are buffer systems that are classified according to the Sorensen pH scale. Remember yung Sorensen pH scale? That's the pH scale 1 to 14. So yung Feldman's, yung kanyang controlled pH will be at 7 to 8.2. Ibig sabihin, if you want to preserve a system, sample pagkain, gusto mo i-preserve at a pH of 7.9, you can use Feldman's. Kasi yung kanyang kinokontrol na pH will be at 7 to 8.2. The board exam question here will be, you're going to match the name with the pH control. You're going to match the name with its controlled pH. That's for Feldman's, 7 to 8.2. For Gifford, 6 to 7.8. Gifford, 6 to 7.8. So tingnan nyo, yung Gifford, it is relatively at the acidic end. Gifford is relatively at the acidic end. And Feldman's is relatively in the basic end. But Atkins, kung mapapansin nyo, very basic yung allowable. Ano? Very basic yung allowable. You should also know that Feldman's, Gifford, and Atkins all utilize boric acid as the primary buffer system. Boric acid, boric acid, boric acid. Feldman's and Gifford will differ on the additional salt that is utilized. Feldman's will utilize sodium chloride, and Gifford will utilize potassium chloride. Feldman's will utilize sodium chloride, and Gifford's will utilize potassium chloride. Another difference will be Feldman's will be isotonic. Ibig sabihin, if you are going to prepare a drug solution that you are going to, in the future, not just in the laboratory where you do experiments, but in the future, compound for the patient, it is better to use the Feldman buffer system. Kasi isotonic siya. No? If gagamit ka ng Gifford buffer system, which is hypotonic, this is limited to use in external surfaces. Sa balat lang. Hindi pwedeng ilagay sa mata, sa ilong, o sa tenga. Kasi yung Gifford hypotonic, only the skin can tolerate differences in tonicity. Kung magka-come in contact na siya with physiologic solutions, tears, saliva, vaginal secretions, no? Earwax, no? The fluids inside the ear, it is better to use Feldman's. If magka-come in contact lang with the skin, you can utilize Gifford. And etong Atkins, not really utilized in the body, no? In drug solutions. Kasi sobrang taas na nung pH. Di mo alam na nag-11 na yung pH, binigay mo na yung gamot. No? Excuse me. Tapon yung kape. So this slide will tell us the clinical application of the buffer systems. So kanina nasabi natin na yung polyprotic acids, they are weak acids because they do not liberate all of the protons. For example, the bicarbonate carbonic acid buffer system will utilize the acid, carbonic acid, and its conjugate base bicarbonate. No? Bicarbonate, carbonic acid, this is the conjugate base, bicarbonate, and this is the acid, weak acid, carbonic acid. Remember that carbonic acid is formed by the union of carbon dioxide and water under the catalysis by carbonic anhydrase. No? So you need an enzyme which is present in the surfaces of cells, which is carbonic anhydrase, to cause the combination of carbon dioxide and water to form carbonic acid. Therefore, we now have, connect natin sa pharmacology ninyo, ano? We now have a biologic system whereby if we inhibit that, we can manipulate the pH of the body. So for example, yung mga umaakyat ng bundok, no? Mga umaakyat ng bundok, as the oxygen tension in the air decreases because of increasing altitude, the body will try to naturally compensate by increasing the respiratory rate. Hinga ka ng hinga dahil konti lang yung oxygen na nasa hangin para bumalanse yung pumapasok sa katawan. But what happens is, as you breathe and breathe and breathe more, the pH of the body falls. Why? Kasi you are expelling more of the carbon dioxide. You are experiencing respiratory alkalosis. Ano? So, anong gagawin? When you have respiratory alkalosis, symptomatic yan. Merong pins and needle sensation, and then para kang magpa-panic breathing. No? So, ang ginagawa ng mga mountaineers, this is off-label use, by the way, they will take acetazolamide, which is a carbonic anhydrase inhibitor, so that more of the carbonic acid will stay in the plasma. No? So that kahit in high altitudes, they won't have to breathe more. Diba? Parang counterintuitive. Pero yun yung purpose niya for mountaineers. So that they can acclimatize with the increasing altitude. So let's go back. Bicarbonate and the carbonic acid system buffer is utilized by the lungs and the kidneys. Your phosphate buffer is utilized by the cells. Yung sinabi ko kanina, where there is an abundance of phosphate, and in the kidneys, particularly in the principal cells that control pH. The intercalated A and B, nandun yung ating buffer system yan. And lastly, hemoglobin. Remember the structure? You have globin, and you have iron in the middle. Surrounding the porphyrin ring is your globin chain. So, yung red blood cells ninyo, dahil maraming protein, maraming globin na protein, and yung globin that's made up of amino acids, no? And your amino acids, the ends of the amino acids are not in the Zwitter ionic form. So kukuha yun ng mga protons. So the plasma proteins, hemoglobin, also has a buffer capacity. No? Kukuha siya at magtatapon ng protons kung kinakailangan. Next, you have the concept of acidosis and alkalosis. So our allowable range is 7.38 to 7.42. But if you are cramming na, you just remember 7.4. Anything below 7.4 is acidosis. Blood ito ha. And everything above 7.4 is alkalosis. But the range is, strictly speaking, 0.38 to 0.42. Now, the one question in the around 1, there will be patok to na question eh. The different pH abnormalities in plasma. So you have metabolic acidosis and alkalosis and respiratory acidosis and alkalosis. So ganito lang. When you say alkalosis, the pH of the plasma is above 7.4. When you say acidosis, the pH of the plasma is below 7.4. Ngayon, pag sinabi mong metabolic, you just look at bicarbonate. No? Pag yung bicarbonate is low, ibig sabihin yung level ng bicarbonate in the blood is low. That is metabolic acidosis. Remember that your bicarbonate is a conjugate base. Therefore, if its level in the plasma is low, nothing will neutralize the acid. And therefore, your plasma will be acidic. But what type of acidosis? Dahil konti yung bicarbonate, metabolic acidosis. No? If sobra yung bicarbonate, metabolic alkalosis. Kasi remember, bicarbonate is a conjugate base. Too much bicarbonate will leave the plasma alkalotic. No? Next, respiratory acidosis and alkalosis. Same pa rin, tingnan mo lang yung pH ng plasma. But this time, dahil ang ating descriptive term is respiratory, we look at carbon dioxide. No? Remember that carbon dioxide will combine with water to form carbonic acid. And therefore, too much carbon dioxide in the plasma will naturally equate to more carbonic acid. And therefore, pwede mong sabihin, although not technically, that carbon dioxide will give acidity. No? So if there is too much carbon dioxide, as for example, in diseases where you are not able to breathe correctly, you're not able to expel the carbon dioxide, there is respiratory failure, hindi humihinga, hindi nag-work yung lungs mo, carbon dioxide will pool in the blood. That will decrease the pH, respiratory acidosis. Common in lung disease, no? COPD, respiratory failure. Next, respiratory alkalosis, just think over breathing. You're breathing too rapidly and too deeply that you are expelling more of the carbon dioxide than what should be expelled. So that dahil sobrang konti na ng carbon dioxide, sobrang konti nang nafo-form na carbonic acid, and therefore, the in the blood falls, and you have alkalosis. But it is due to carbon dioxide. So it's respiratory. I will not teach you the compensation. Sa ano na lang, sa pharmacology ko na lang ituturo. Okay. Wow, umabot tayo sa thermodynamics. Sabi natin in the introduction to chemistry, that chemistry is the study of matter and the changes that it undergoes, including the energy that drives these changes. So, yung portion of chemistry that will tell us of the changes in the energy that drives the chemical change, that's thermodynamics. No? So, yung thermodynamics, toxic yung computations, pero relatively maiintindihan naman kung bakit siya ganun. What's important is you know the concept, no? Para hulaan mo na lang, hulaan nyo na lang yung formula, no? It is better to know the concept and derive the formula than memorize the formula. You have the thermodynamic system. What is a system? So, it's any part of the universe that is isolated from the universe. Sobrang matalinghaga ng mga terms. Pero technically, you have a bigger environment and then you have a smaller environment separated from the bigger environment by a wall that is impenetrable. So that smaller environment is a system. No? Any part of the universe isolated from the rest of the universe by a boundary or a wall. So yung ating environment or surrounding is everything outside the system. It's everything outside the system. Ulitin ko, yung buong universe, if you have a wall or a boundary that you are able to isolate a part of the universe, that is the system. Sobrang toxic, basta isipin nyo lang na when kang bigger thing, then you have a smaller thing that is separated from the bigger thing by a wall. So that wall plus the smaller thing, that's the system. Everything outside the system is your surrounding. Okay, so in terms of the systems, we have three types: the open, the closed, and the isolated. So, ang open system, ibig sabihin yan, there is free communication with the internal system and the environment. Nag-uusap. In what way? Matter and energy can come and go freely. Nag-exchange, no? Yung matter and energy. There is free communication. That's an open system. An example of an open system will be the human body. Example ng open system is the human body. Anong nangyayari? Kapag kakain ka, matter comes in. And your cells metabolize the food. No? Your cells metabolize the food. And they liberate the energy from the bonds in your food stuff. No? As you oxidize the food material, you liberate the energy. And you use the energy to power the processes of the body. But take note, you have to release some of the energy in the form of heat. So, yung heat, nare-release mo to the outside environment. Yung kinain mo, it becomes water and carbon dioxide, basically. And yung carbon dioxide, you release again to the environment. So, there is a free-way exchange of matter and energy. A closed system will allow the exchange of energy but not matter. Closed system, yung makaka-communicate na lang energy, but matter is conserved inside. Closed system, matter is conserved inside. only energy can come and go. So an example of this will be a container with a lid. Kung meron akong takip, container na to, matter cannot escape. But definitely mayroong lalabas na heat dyan. No? Energy can escape and enter. So that's a closed system. However, if I use thermodynamic insulation, no? Kung meron akong insulator, nilagay ko yung material at saka yung much of the energy that comes with it. Example, hot water, and then you have a thermos mug. No? Let us assume this is an ideal isolated system. The energy in the hot water and the water itself is just inside and it can never escape. That water will stay warm forever. No? Will stay hot forever. So that is an isolated system. There will not be an exchange of both energy and matter. Open system, free exchange. Closed system, energy lang makaka-exchange. Isolated system, no exchange at all. Okay. So, let us move to terminologies. Heat capacity, that's the amount of heat that is needed to raise the temperature of a substance by 1 degree Celsius. So, kailangan natin ngayon i-differentiate ang heat and temperature. No? So, yung heat, isipin niyo lang energy yan. Heat is energy. Temperature is my measurement of that energy. No? Para bang kung yung katawan, yung heat, yung thermometer, yung temperature. Okay? Na-imagine niyo ba yung analogy? Heat is the energy itself. And in order to understand how much heat is there, I'm going to use temperature. Okay? So heat capacity, balik tayo. You have a system. No? That system has a finite, a distinct amount of particles. Okay? So, mag-i-imagine na kayo guys ha, as a distinct amount of particles and a distinct level of movement of those particles. Gumagalaw siya, no? At a particular degree, no? Heat capacity will be the amount of heat that I will add into the system so that the particles in that system will move just a little bit more so that I get a reading of 1 degree Celsius more. Okay? Kuha niyo yun? So yung heat capacity, it will depend on the amount of material that you have. Yung heat capacity ng isang baso ng tubig, although tubig yung loob, will be less compared with the heat capacity in a swimming pool kung saan tubig din ang loob. No? You will need more doon sa swimming pool. But have you raised the temperature by 1 degree Celsius in both systems? Yes. So magkaiba yung heat capacity. Ngayon, kung gusto mong i-compare yung heat in the swimming pool and heat in the glass of water, gram per gram, no? So, ibig sabihin, 1 gram ng tubig sa swimming pool and 1 gram ng tubig dito sa ating baso ng tubig. Dahil tubig silang dalawa and dahil equal sila na 1 gram, magkapareho yung specific heat. No? Kung ano yun? Yung swimming pool, magkaiba yung kanyang heat capacity sa baso ng tubig. But it has the same specific heat dahil tubig pa rin siya, yung 1 gram na ating kincompare. So, specific heat is the amount of heat required to raise the temperature of an object by 1 degree Celsius per gram. Okay? Paano yan? Very important. Kasi in your, this is a physical pharmacy question. So mapapansin nyo yung Gen Chem, yung automatic extension niya is physical pharmacy. Kaya when you review your module 5, mag-review din kayo ng Gen Chem. Okay? Okay. Mayroon mga questions sa physical pharmacy na you have a specific heat of this material. You have this amount of material. The environment is this hot and the material is this hot. What is the specific heat? What is the heat capacity? Those kinds of questions. Next, we now define heat. Just think of heat as energy. No? Heat is just energy. What kind of energy? It's an energy that moves. It transfers from one system to another. Kailan siya nagta-transfer? Kapag magkaiba yung temperature. No? So, ulitin ko. Heat is energy that moves. It's an energy that transfers from one object, from one system, to another object or another system. It moves between two systems. But what dictates how it will move? That's temperature. It will always move from one system with a higher temperature to another system with lower temperature. No? So for example, balik tayo dun sa swimming pool at sa baso ng tubig. Kung yung swimming pool mo, ang temperature, so ang nasa swimming pool, puno yung swimming pool ng tubig, yung temperature ng tubig doon ay let's say, 20 degrees Celsius. No? Temperature of 20 degrees Celsius. Yung baso ng tubig, kahit ganun na siya kaliit, but yung temperature niya 100 degrees Celsius, heat will still move towards the swimming pool. Kahit mas marami yung heat capacity or total heat ng swimming pool. Kasi yung temperature magkaiba. Na? Paano yung difference? Work, in terms of thermodynamics, will be the same as in physics. Work is force applied over a distance. Now, work, force applied over a distance. Paano mo napapagalaw? No? By how much? How much distance? Gano'ng kabigat yung ginalaw mo? Work. No? That's in physics. But here, in thermodynamics, we refer to work almost exclusively in gases. Why? Kasi yung gases, they are expansile and they are compressible. Ibig sabihin, when you move a gas from constricted to expanded, you form work there. And from expanded to constricted, from being in this state, you compress it into this much. You did work already. So it's a form of energy transfer that utilizes compression or expansion of a gas. No? For example, yung refrigerator ninyo, kukuha siya ng heat from the food and it compresses the gas, the freon inside compresses. As it moves into the exterior or the topmost portion of yung radiator sa likod, it will again expand and release the heat. So there is work being done by your refrigerator. Same as with your air conditioner. So work done by the system, that is expansion. Work done by the system is expansion. So example, ito yung aking system, yung aking kamay. Ito yung environment, yung outstretched palm. When the system does the work, it expands. But when the environment does work on the system, ito yung nag-a-apply ng force, it compresses. Kung ano yan? Done by the system. If the work is done by the system, the gas, it's expansion. But if the work is done on the system, on the gas compresses. That's compression. Okay? Okay. So, it has been another 1 hour. Kaya, break muna tayo ng 10 minutes ulit. And then, dire-diretso na hanggang tapos natin yung 15 minutes. Okay? Break muna. Kain siguro kayo ng matiwasay for 10 minutes. Okay. So, recap natin yung thermodynamics. It's the study of the changes of energy as chemical reactions occur. So, kanina nalaman natin ano yung mga particular definition of terms used in thermodynamics. So, ngayon naman we'll be trying, although this is a very difficult concept, understand why some reactions are favorable and the others are not. Why some reactions are spontaneous and the others are not. So, ganito lang. Yung ating goal sa thermodynamics ay i-predict kung mangyayari ba yung reaction or hindi. Okay? So, yun yung primary natin na concern as pharmacists. Kung mangyayari ba yung reaction na gusto natin or hindi. For example, kapag magko-combine ka ng phenol at saka ng ether, will there be union or wala? Anong pwede mong gawin? So, yun yung mga practical pharma applications ng thermodynamics. So, first, I'm going to introduce you to the concept of internal energy. So, yung system na ating tinutukoy kanina, everything that is a smaller part of the universe, which is separated from the universe by a boundary or a barrier, if your system is an isolated system. Remember niyo yung isolated, walang exchange ng matter and energy. If it's an isolated system, easy lang yung ating pag-determine ng internal energy. Pero, most systems are closed systems. Heat lang yung pwede nating idagdag or tanggalin. So, kung mapapansin nyo, sa paggamit pa lang ng heat, marami na siyang pwedeng gawin. No? It can drive a reaction to occur or not. So, yung total energy of the system, we refer to this as internal energy. Total energy of the system, including the heat in there and the kinetic energy of the molecules that comprise the system. No? Yung mga pinag-uusapan natin, ionic energy, electrostatic force, nuclear force, inter and intramolecular forces of attraction, those are all energies in the system. No? Internal energy is abbreviated as U or E. U or E. So, the change in internal energy is equal to the heat added to the system. Remember, we're talking of closed systems, no? Pwede tayong magdagdag ng heat, but we can't take away or add matter to the system. Heat added to the system minus work done by the system. Okay? So, bakit ganun ang ating formula? Delta U is equal to Q minus W. Bakit ganun ang ating formula? Internal energy increases as you add energy to the particles. Easy to understand yun. Pero, paano yung work done by the system? Remember that when we talk of work, we are basically converting heat energy into movement. We're trying to cause the particles of the gas or the fluid to compress or to expand, no? Yung heat na ating idadagdag or yung heat that is already in the gas, it will cause the gas to expand or collapse. Habang gumagalaw yan, sa pag-expand niya or sa pag-collapse niya, it loses heat to the environment. So basically, naiintindihan niyo na, yung heat na dinagdag nyo, that becomes part of the internal energy. But remember, as you try to move things, you're expending energy. Kaya siya work, no? You're expending energy to cause a substance to move from one point to another. You're expending energy there. Kaya tayo minus W, no? So, delta U, internal energy, is equal to heat added to the system Q minus work done by the system. So, another term that you should be familiar is isochoric, the term isochoric. So, yung term na isochoric, ibig sabihin nun, yung heat remains the same, heat in a system with constant volume. Okay? So, ano ibig sabihin nun? Yung volume inside a closed system is constant. What is the heat in that system of constant volume? We use the heat descriptor isochoric. That's how you describe the heat. If the system has constant volume, no? Isochoric. So, you have state functions. Ano ibig sabihin ng state functions? When you're trying to understand thermodynamics, yung state functions para siyang mga intrinsic properties. No? In a particular system, um, ito yung mga parameters that will describe the system. No? So you have two. First is enthalpy, H, and the second one is entropy, S. So enthalpy, merong H sa spelling. O ganun na lang pag-memorize ha. Enthalpy, may H sa spelling, so siya ay H. Entropy, wala kayong other way but to remember S. Okay? So enthalpy is the heat content at constant pressure. And pag sinabing constant pressure, yung other way to say constant pressure, isobaric. No? So enthalpy is heat content at a constant pressure. Bakit ba? Pag binago ko yung pressure, magbabago ba yung heat content? Yes. Because if you change pressure, the pressure of a system, the molecules will tend to move more or move less. No? So when it moves more or moves less, together with the movement is expenditure of heat. Kaya to measure heat, kailangan constant ang inyong pressure. To measure heat, it should be isobaric. Enthalpy is the amount of heat in an isobaric system. Entropy is basically the degree of disorder in a system. And later on, de-describe natin ano yung relationship ng entropy and enthalpy. Ano? Entropy, degree of disorder in a system. Gaano ka wasak yung system ninyo? That's entropy. No? So next you have the thermodynamic loss. So other way of saying this, laws of thermodynamics. No? Meron tayong apat, but here, tatlo lang natin pinakita. Yung pang-apat is the zeroth law. No? Familiar? Zeroth law of thermodynamics. Yung zeroth law, you will encounter it in physical pharmacy. It states that a crystal, a perfect crystal, has zero entropy. No? A perfect crystal has zero entropy, zeroth law. So, first law of thermodynamics. Paano tinatanong sa board exam ang laws of thermodynamics? They will ask, they will say the content of the law, then you're going to determine if it is the first, second, or third. So, ganun yung question sa law of thermodynamics. The first law is the law of conservation of energy. So, ibig sabihin nito, energy cannot be created nor destroyed. Nagbabago lang yung kanyang forma. So, for example, the energy in 1 gram of starch, so yung starch is carbohydrate, it's 3.4 kilocalories if it's anhydrous form, no? And 4 kapag hydrated form. 4 kilocalories per gram. So yung 1 gram of starch, is 4 kilocalories. Yung 4 kilocalories na yon, pag hindi pa siya na-metabolize ng katawan, it's still in the form of chemical energy. But once it has been metabolized by the body and used by the processes, which are not perfect, ibig sabihin, they will always have to lose some form of energy in the form of heat. The chemical energy is converted to mechanical energy. For example, in detaching and attaching the myosin heads in actin and myosin. That's mechanical energy already. Yung pag-lose mo ng heat, as body heat, that's thermal energy, heat energy. From chemical, you form mechanical and thermal. So, just the same. Pero hindi naman natin na measure yung heat loss talaga. So, di natin masabi. No? Okay. Teka lang. Okay. Next, the second law of thermodynamics is the law of progressive entropy. The second law of thermodynamics is the law of progressive entropy. Ano ibig sabihin nun? Lahat ng nangyayari dito sa universe, o mga universe kasi yung ating terminology sa thermodynamics. Lahat ng nangyayari sa universe occurs in such a way that at the there will always be increased disorder. No? Things will happen only if it will lead to increased chaos. So, sa inyong mga biochemistry books, no, you're going to read biochemistry, it will say sa thermodynamics na part na life is basically just one thing, trying to slow down entropy. So life is trying to slow down entropy. Ano ibig sabihin nun? For a chemical reaction to occur, the total energy and the total orientation of particles should be in such a way that at the end of the reaction, more disorder resulted than from the original system. Paano yan? So, ibig sabihin, dahil yun yung law ng universe, we can never really, we can never really, paano ba, i-recapture lahat ng na-lose ng isang system back towards the system. There will always be something to lose for a reaction to occur. Okay? So, ulitin ko. The second law of thermodynamics is the law of progressive entropy. Changes will always occur so that at the end of the change, more disorder has resulted. The entropy of an isolated system always increases. The third law of thermodynamics will say that the entropy of a system will become constant as the temperature becomes zero. So this is absolute temperature, ha? So 0 Kelvin, negative 273.15 Celsius. Kapag lumalapit ka na sa 0 Kelvin, yung entropy ng inyong system, hindi na siya magbabago. Okay? Kung ganun yung entropy niya, ganun na talaga siya. Hindi na siya magiging more disordered as you approach 0 Kelvin. That's the third law. First law, energy is not created nor destroyed. Second law, systems will always have more entropy. Third law, if you freeze to absolute zero, entropy will be preserved. It will not increase anymore. Zeroth law of thermodynamics will say a perfect crystal has zero entropy. Perfect siya. Perfect yung pagkaka-arrange ng mga molecules in the crystal. Why did I place this slide here? Kasi for you to understand Gibbs free energy, kailangan naintindihan nyo yung second law of thermodynamics. No? Gibbs free energy. So, yung Gibbs free energy, it is just a measure of the difference in enthalpy, which is the enthalpy, which is the heat energy, potential energy in the particles, the temperature, the pressure, and the entropy. So, dito muna tayo mag-intro muna tayo. Ito yung formula nating Gibbs free energy. Laser pointer. Gibbs free energy. This is enthalpy or internal energy. entropy or the state of disorder, the temperature, the pressure, and the volume. So, ganito. Determining Gibbs free energy will tell you if the reaction will proceed or not. No? Determining Gibbs free energy will tell you if the reaction will happen or not. So, ito yung ating, please memorize this table, guys. Or kahit familiarize lang or intindihin niyo lang. Yung ating reactions, they will occur if it is spontaneous. But in biochemistry, you will be taught how to couple reactions. No? So, sa biochem na yun, di ko na yun itatouch. So, if your reaction is spontaneous, it will occur. When will a spontaneous reaction occur? Remember the second law of thermodynamics. Para maging possible ang isang pangyayari, isang reaction, kailangan tumaas yung disorder. No? So, paano tataas yung disorder? Kung ang entropy tataas, yung disorder tataas, it is spontaneous. Yung ating reaction, yung ating system will proceed with the change. Kasi more energy has been lost by the system became more disordered. So it will satisfy the second law of thermodynamics if you increase entropy. Ngayon, enthalpy, sabi natin that's internal energy. Ano ba yung energy in a system? Those are the forces that hold atoms in compounds. Those are the forces that hold molecules in a state of attraction, inter- and intramolecular forces of attraction. Nuclear energy, electrostatic energy. No? Those are the different manifestations of internal energy. Ngayon, those energies, those forces are convertible to heat. No? Those forms of energy, those forces are convertible to heat. Therefore, we also call enthalpy as internal heat. No? Enthalpy is also known as internal heat because of the convertibility of those energies. Remember, those forces of attraction will hold atoms and molecules together. Siya yung magpapadikit sa mga particles. And therefore, it is the one that determines order. Nakuha niyo na yon. Enthalpy is the one that will oppose entropy. The attraction between the particles will be the one to hold the particles together so that they do not become disordered. That's enthalpy. So ngayon, balik tayo. The second law of thermodynamics will tell us na mangyayari lang yung reaction if it becomes more disordered. So how do we make it more disordered? We need to increase the entropy. Kailangan guluhin natin yung mga molecules. We also need to release some of the heat energy from the enthalpic pool. So yung enthalpic pool, yun yung total energy of a system in enthalpy. Kailangan natin i-release yun. Kailangan kumonte, kaya siya negative sign, yung enthalpy. Okay? So, For a reaction to be spontaneous, enthalpy must be negative, entropy must be positive. And this negative enthalpy is coupled by a release of the energy, kaya siya exothermic. Ano? So, balik tayo. So, ito yung meat ng discussion. Ano na? Focus kayo. If you release some of the energy into the environment, the total energy in the system decreases. If you release some of the energy in the system towards the environment, the total energy in the system decreases. Kasi tinapon mo nga sa labas. Therefore, pansinin nito, the Gibbs free energy, the total energy in the system from the original level of energy decreases. Kasi tinapon mo sa labas. And therefore, if a reaction is exothermic, you release the energy, you decrease the enthalpy, you increase the entropy. A delta G, a Gibbs free energy of less than 0 is spontaneous because it will facilitate, it will agree with the second law of thermodynamics. No? If the Gibbs free energy of a reaction is greater than 0, the reaction will not occur because it is non-spontaneous. So there has to be a way to remove that excess energy so that it becomes more negative. There has to be a way to decrease the Gibbs free energy. And that is done in your biochemistry by coupling reactions. No? That is why when you make, example, fatty acids, 2 carbons, 2 carbons, 2 carbons, 2 carbons, pag didikit mo yun to make a fatty acid, that's an anabolic reaction that is always partnered with the hydrolysis of ATP, which loses energy. The total, the combination of the anabolic reaction and the catabolic reaction of the hydrolysis of ATP will yield you negative total Gibbs free. Kaya mangyayari pa rin yung inyong lipogenesis, fatty acid synthesis. Na? Kahit kung titingnan mo, acetyl-CoA, 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 the energy there is positive delta G. But dahil pinartner mo siya with the hydrolysis of ATP, magiging negative delta G yung overall Gibbs free energy. Kaya mangyayari yung anabolism, formation of fatty acid from acetyl-CoA. Okay. Gibbs free energy is then expendable amount of energy. Ito yung ating total energy. Tatanggalan mo ng entropy. Teka lang, I have a call ha. Okay. Pansin nyo dito na ang ating change in Gibbs free energy will always be equal to the difference of enthalpy U minus the product of temperature and the final entropy. Kaya ang ating easy way of remembering this would be gatas, no? Delta G delta H minus delta T and S. Gatas. Spendable amount of energy. So, the internal energy, how much was it disordered? How much did it give away to the environment? So, yun yung ating, yun yung ating interpretation. Total Gibbs free energy will be determined by the total enthalpy, total enthalpy. How much of that enthalpy was given off to the environment in the form of heat, and how much disorder has resulted from it. So, if our Gibbs free energy is negative, then the reaction, the change is spontaneous. It will follow the second law of thermodynamics, and therefore it will occur. So meron tayong pamim dito na joke. Sabi niya, what do I say to her? Sabi ng friend, bro, just be spontaneous. Girls love that. As yun yung ginawa niya. Noted. Okay. So, chemical kinetics naman. So, kanina, matatapos ko ba to in time? Sige. Introhan na lang natin. So, chemical kinetics. Kung kanina, dinetermine natin sa thermodynamics if a reaction will proceed or not in the first place. Yun yung role ng thermodynamics. To tell us if a reaction will proceed or not in the first place. If it does proceed, how fast or how slow will it proceed? That's chemical kinetics. No? Chemical kinetics. That's the study of reaction rates. So dito mag-a-apply yung inyong Le Chatelier's principle. No? So we have different theories on chemical kinetics. Ano ibig sabihin ng theories of chemical kinetics? Ibig sabihin nito, ano yung mga sa tingin natin ways upon which the reactions occur? The first theory is the collision theory. Chemical kinetics, the first theory of reaction is the collision theory. In all reactions, yung mga reactants dapat magbungguan, must undergo collision to form the products. Kapag hindi sila nagbungguan, if hindi sila nagkadikit sa isa't isa, walang reaction na mangyayari. Apply natin sa biochem ninyo. Remember that one principle of catalysis by enzymes will be to place the reactants closer to each other. No? So if hindi sila magkadikit, hindi mabilis yung reaction. Kaya ang ginagawa ng enzymes, one theory of enzyme kinetics is ipagdidikit, i-oppose noong active site, noong enzyme, yung dalawang reactants para dahil magkadikit na sila, mangyayari na yung reaction, mas mabilis nang mangyayari. Kaysa random magbungguan sila kahit anong direction. Rate is dependent on the frequency of collisions. So, balik tayo sa kinetic molecular theory of matter. Kung sabi dito, rate is dependent on the frequency of collisions. By making the molecules more active, more kinetic, no? They move a lot faster. when they move a lot faster, they will have more collisions with each other. And therefore, the rate of the reaction is increased. So yun yung reason bakit pag ininit mo ang isang test tube na may reactants, bakit mas bumibilis? No? Kasi the effective collisions, the frequency of the collisions increase. So according to the collision theory, you have two determinants. So you have two requirements for the collision theory. First would be energy requirement. Kailangan yung reactants ninyo, mataas yung energy. The reactants must have high energy. Why? According to the law of thermodynamics, there must be initially high energy that upon the reaction, energy is lost and the total energy goes down. As the energy is lost, entropy is increased. So your reactants must have high energy. The point from which the reactant is at a low energy level and the energy level is progressively increased, so by whatever means you have, no? Agitation or increasing temperature, as you increase the energy of the reactant, it reaches a point where energy is high enough that the reaction can proceed downwards, down the hill. So, yung point from low energy to high energy, that is your activation energy. That activation energy must be overcome by the reactants for the reactants to form the products. So yung activation energy natin is also known as the energy barrier. No? You need to overcome the energy barrier for the reaction to occur. The next would be proper orientation. So molecules are three-dimensional objects. Ibig sabihin, 3D. Kung magbabanggaan sila, pwede in many different phases, in many different axes. No? So, pwede nakatabingi, naka-straight, yung molecule ninyo. Kaya, kailangan parang naintindihan konti, kahit konti lang, yung stereochemistry ng inyong organic chem. No? Para maintindihan yung orientation. For reactions to occur, the orientation of the reactants must be so precise that this part of the molecule collides with this corresponding part. If no, if the corresponding parts do not orient correctly, no reaction occurs. So ito yung principle ng inyong functional groups ng inyong amino acids, no? Ng inyong mga macromolecules. For example, for alcohol, which has the functional group OH, for it to form an ether, no? The reactive alkyl group of the ether, kasi three-dimensional yan. For example, ito yung reactive alkyl group. Ito yung hydroxyl group ng alcohol. Tapos ito yung R group ng alcohol. If yung R group yung didikit sa reactive alkyl group, walang reaction mangyayari. No? But if the reactive alkyl group associates in the proper orientation with your functional group, the hydroxyl group, an ether is formed. So, for the collision theory to occur, for the collision theory of reaction to occur, there must be overcoming of the energy barrier, and there must be correct orientation of the colliding molecules, no? Para mangyari yung reaction. Okay. So, it's already 9. Do you have questions before we end?
None, sir.
No questions? Sorry, di ko rinig.
Wala po.
Wala. Okay. So, ulitin ko lang yung tips ko, mag-aral at magpahinga. Always partner yung dalawa. Okay? So, kapag nagpapahinga, dapat yung tulog, hindi yung hindi yung social media or Netflix. Okay. Sige. See you next time. Inform ko na lang si Ma'am Reza, review manager niya. Thank you.
Okay, sir.
Thank you
Thank
po,
you.
sir.
Good night.